Hello everyone, welcome to my channel. This video is a quick review of the Doppler's effect in sound. Now, as we know that if this is the source and this is the listener, now if the separation is decreasing, either this is source is moving towards listener or listener is moving towards source. If the separation is decreasing, then the frequency will increase. Okay, and there's the opposite of that. If the listener is moving away or the source is moving away such that the separation is increasing, the apparent frequency will decrease. Okay, so this is the basic idea. So there is a change in the apparent frequency, or apparent frequency changes due to relative change in the position of source or listener or both. It's called Doppler's effect. Now, the general formula for apparent frequency is f dash is equal to f v plus minus vl divided by v plus minus vs. Okay, now here v is the speed of sound, VL speed of listener, and VS is speed of source. Speed of source. F is the actual frequency. F is the actual frequency. And this is the apparent frequency or the observed frequency. So now see how this relation is used for various cases. See, in numerator you have listener, denominator you have source, and the basic concept is if the separation is decreasing, the frequency separation between source and listener is decreasing, the frequency, apparent frequency should increase. If the separation is increasing, then the frequency, apparent frequency will decrease. So let us see the various cases. So we have, suppose you have first case, source is moving towards listener. Okay, source is moving towards listener and the listener is stationary. So listener is stationary means VL is equal to 0. Now since source is moving towards the listener, the frequency should increase. Source velocity is at the denominator. So if you decrease the denominator, the frequency, if you decrease the denominator, the frequency will increase. So the expression will be f prime or f dash equal to f v divided by v minus vs. So similarly, if you have a source which is moving away and the listener is stationary, so now since the separation in this case it is increasing, the frequency, apparent frequency should decrease. So you have f dash is equal to f v plus vs. Okay, so similarly we can write the formula for when the listener is moving towards, you can write apparent frequency is equal to f v plus vl divided by v. In this case source is stationary. Okay, now suppose you have a case wherein you have source and this is the listener. Source is moving towards the listener with velocity vs, listener is at rest, so vl is equal to 0, and suppose wind is also blowing. So this is the velocity of wind and this angle is theta. So now this is the component of wind velocity in the direction of the line joining the source and the listener. So this is Vw cos theta. Okay, so now that means this component of velocity of wind is flowing in the direction in which the sound is propagating. So this will help the sound to propagate. So in this case, the velocity of sound v, it is replaced by v plus Vw cos theta. V plus Vw cos theta. Okay, so that now See, if we don't consider this expression, so if there is no wind blowing, in that case, for this particular situation, the apparent frequency will be f dash is equal to f v divided by v minus vs. Since source is moving towards the listener, the motion of source will contribute the increase in frequency. Source is vs is at the denominator, so it is v minus vs. Now, since if the wind is blowing, v has to be replaced by this. So now we will have f dash is equal to f v plus vw cos theta divided by v plus vw cos theta minus vs. Okay. Now, in case wind is blowing in this direction, vw, so this will be vw cos theta. So in that case, the wind is blowing in opposite direction, so it will be v minus vw cos theta. V will be replaced by v minus vw cos theta. Okay. So this is the case when wind is blowing. Now another case, suppose you have source, this is the source, this is the listener. Okay, the source is moving in this direction with velocity vs, listener is moving in this direction with velocity vl. This angle is theta s, this angle is theta l. Okay, so now in this case you have to take the component of velocities which are along the line joining the source and the listener. So for vs, this will be vs cos theta s. That means source is approaching listener with this velocity. Similarly, listener is approaching the source with velocity vl cos theta l. Okay, so in this case the apparent frequency will be f dash is equal to f. Because of the motion of listener, the frequency should increase. Listener velocity is at the numerator, so it will be v plus vl cos theta l divided by v minus vs cos theta s. Okay, so as you can see in this case, if the source and listener, they are moving in a line in a direction perpendicular to the line joining them. So if source is moving in this direction such that this angle theta is 90, theta s is 90 degree. Similarly, listener is moving in this direction and angle is again 90 degree. So both these terms will be 0. So in that case, apparent frequency will be equal to actual frequency. So Doppler effect will not be observed in case they are moving source or listener, they are moving perpendicular to the line joining their positions, respective positions. So these are the few important concepts of Doppler's effect which will be helpful for solving questions in your forthcoming JEE examination as well as NEET examination. And you may also check that in this case, if the source and listener, for the wind blowing, if the source and listener they are at rest and wind alone is blowing, you will see that again, suppose this is source is at rest, wind alone is blowing, so you will have v plus vw cos theta, v plus vw cos theta. This cancels out, apparent frequency equal to actual frequency. So if source and listener they are at rest and wind alone is blowing, no Doppler effect will be observed. Okay, so these are the few important concepts on Doppler's effect. Good luck for your forthcoming examination.